Okay, hello everyone. In this video, we are going to discuss about numericals based on Laplace transform of derivatives, then numericals based on Laplace transform of integrals. Actually, in our last class, we have been discussed about Laplace transformation of derivatives. We found that Laplace transform of nth derivative of a function ft is your s to the power n capital Fs minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash 0 minus s to the power n minus 3 f double dash 0 and so on, and last term would be f to the power n minus 1 0. We proved this one, and then we have been discussed Laplace transform of integrals. In detail we have been discussed. In this video we are going to discuss corresponding numericals. So I suggest before you are going to watch this video, you just recap the previous video. Okay, so the question belongs to Laplace transform of the derivatives. First question is that given that Laplace transform of 2 into root over of t by pi equal to 1 by s to the power 3 by 2, then we have to prove that Laplace transform of root over of pi by t will be equal to 1 by root over of s. Okay, this question we are going to solve using Laplace transform of derivatives. Let ft equal to 2 into t by pi or root over. So here this is the function. Directly we consider ft as your 2 into t by pi root over. So first derivative of this ft will be equal to how much? 2 into 1 by 2 into t by pi to the power minus 1 by 2. Okay, because here this power will be 1 by 2. So 1 by 2 to the power 1 by 2 minus 1. So obviously this will be minus 1 by 2. And here 2 got cancelled, and we found t by pi to the power 1 minus 1 by 2 or pi by t to the power 1 by 2. And here ft will be this much. If I will consider f of 0, then here t will be 0. So f of 0 will be 0. Now we are going to consider Laplace transform of derivatives. Laplace transform of derivative, first derivative of the function, we know that here first derivative is your s f of s minus f of 0. This is capital Fs. Okay, so s into Laplace transform of f of t. Here you can see this capital F of s is nothing but Laplace transform of f of t. So s into Laplace transform of f of t minus f of 0. So this is nothing but from your Laplace transform of derivative. S into Laplace transform of function, here we consider 2 into t by pi root over minus f of 0 is 0. Here 2 is constant taken outside. 2s by root pi also. Root pi is constant taken outside. Root pi Laplace transform of t to the power 1 by 2. Then 2s by root pi. Here Laplace transform of t to the power 1 by 2 will be equal to gamma 1 by 2 plus 1 by s to the power 1 by 2 plus 1. Because already we know that Laplace transform of t to the power n is nothing but gamma n plus 1 by s to the power n plus 1, or gamma n plus 1 is nothing but n factorial by s to the power n plus 1. So here n is nothing but 1 by 2. So the answer will be gamma 1 by 2 plus 1 by s to the power 1 by 2 plus 1. Okay, so here gamma 1 by 2 plus 1 will be 1 by 2 into gamma 1 by 2 s to the power 3 by 2. Gamma half is nothing but root pi. So 2s by root pi into 1 by 2 root over of pi s to the power 3 by 2. So here 2 got cancelled, and we found s by 2 got cancelled, root pi got cancelled. Here s to the power 3 by 2. So finally we can found s to the power 1 by 2 or root over of s. Hence proved. Okay, Laplace transform of this one will be equal to 1 by root over of s. Second question is your, if Laplace transform of sine root over of t will be equal to root over of pi by 2 into s to the power 3 by 2 into e to the power minus 1 by 4s Then find out the value of Laplace transform of cos root over t by root t. So how we are going to solve it? First we are going to consider our function ft is sine root over of t. Corresponding first derivative will be sine root over t, means cos root over t, and root t derivative will be 1 by 2 root t. And f of 0 means t0, if we are going to put sine 0 will be 0. In general, first derivative and its corresponding Laplace transform of ft will be s. In general, s into Laplace transform of f of t minus f of 0 by considering Laplace transform of derivative. That implies Laplace transform of this f dash t is nothing but this one, cos root t by 2 root t equal to s into f of t is nothing but our sine root t. And already given that Laplace transform of sine root t is root pi by 2 s to the power 3 by 2, we have to just put it s into root pi by 2 s to the power 3 by 2 into this term also is there, e to the power minus 1 by 4s, and your f of 0 is your 0. That implies here 1 by 2 can be taken outside. 1 by 2 Laplace transform of cos root t by root t by equal to 1 by 2. Here you can see root pi is there, root pi, and here s to the power 3 by 2. That means in the denominator it will be s to the power 1 by 2. So pi by s whole root into e to the power minus 1 by 4s. Okay, so that implies Laplace transform of this one will be equal to, here 1 by 2 1 by 2 got cancelled, pi by s root over into e to the power minus 1 by 4s is your answer. Okay, now we are going to go for another question, that is your find Laplace transform of cos 80, then find out Laplace transform sin 80 using Laplace transform of cos 80. Laplace transform of cos 80 will be equal to 0 to infinity e to the minus st into cos 80 dt will be equal to, these things already we have been discussed when we have been discussed Laplace transform of elementary functions. You can check that video. In that video we discussed about Laplace transform of cos 80. Here, seventh one, Laplace transform of cos 80 is your 0 to infinity e to the minus st into cos 80 dt, and using the special integral, this one we found s by a square plus a square. So I suggest to all of you that you just write down this much in your note, or I am going to write over here, will be equal to e to the power minus st divided by minus s whole square plus a square whole into minus s cos 80 plus a into sin 80 0 to infinity. Okay, so this integral value will be this much by using this special integral. Okay, you have to remember this one and also this one. E to the x sin bx is this one, e to the x cos bx is your this one. So by using this one we found e to the st into cos 80 equal to this one, this much, and if I am going to put the limit, finally we can found that s by a square plus a square. Okay, so Laplace transform of cos 80 is your s by a square plus a square. Let this is your equation number 1. Now consider ft as your cos 80 in equation number 1, and f dash t will be minus a sin 80, and f of 0 is equal to 1, because here 0 means cos 0 will be 1. Now we are going to consider Laplace transform of derivative. In general, Laplace transform of first derivative of ft is your s into Laplace transform of ft minus f of 0. That implies Laplace transform of f dash t is nothing but minus a sin 80 will be equal to s into Laplace transform of f of t we consider cos at. That is so hence Laplace transform of cos at is nothing but, here we found s by a square plus a square, and f of 0 is your 1. So by solving we can get minus a square by a square plus a square. So here left hand side one minus minus, so got cancel. Laplace transform of sin at will be equal to, uh, here one a is there, this a and one a will be got cancelled. We found a by a square plus a square is your answer. Okay, next another question is that find out the Laplace transform of root over of sine root over of t. Actually this question is linked with this one. Okay, here Laplace transform of sine root t is given, but if in your exam it will ask that you have to find out the Laplace transform of sine of root over of t, then what will the procedure I written? You can also write in your note. Okay, here only we derived the Laplace transform of sine of root t. Okay, how it is, you carefully watch. We know sine x expansion is your x minus x cube by 3 factorial, x5 by 5 factorial, minus x7 by 7 factorial, and so on. If instead of x we are going to consider root over of t, then root over of t, the series will be root over of t minus root over of t cube by 3 factorial plus root over of t to the power 5 by 5 factorial, and so on. So here you can see this will be t to the power 1 by 2 minus here root t means t to the power 1 by 2. So t to the 3 by 2, t to the 5 by 2, t to the 7 by 2, and so on. Therefore, Laplace transform of sine root over of t will be equal to Laplace transform of this whole. Okay, so Laplace transform of t to the power 1 by 2, then Laplace transform of this term, and this term. As we discussed just now that Laplace transform of t to the n is your gamma n plus 1 by s to the n plus 1, or n factorial by s to the n plus 1. That means also we are going to be used over here t to the 1 by 2. Laplace transform of t to the 1 by 2 is your gamma 1 by 2 plus 1 by s to the 1 by 2 plus 1, minus already 3 factorial at the denominator. So 1 by 3 factorial t to the 3 by 2 Laplace transform will be gamma 3 by 2 plus 1 by s to the 3 by 2 plus 1. Laplace transform of t to the 5 by 2 will be already 5 factorial is there. So 1 by 5 factorial Laplace transform of t to the 5 by 2 will be gamma 5 by 2 plus 1 by s to the 5 by 2 plus 1. Here gamma 1 by 2 plus 1 is nothing but 1 by 2 gamma 1 by 2 minus 1 by 3 factorial. Here s to the power 1 by 2 plus 1 nothing but s to the 3 by 2 minus 1 by 3 factorial into gamma 3 by 2 plus 1 will be 3 by 2 into 1 by 2 into gamma half. How it is? Here you can see the gamma 3 by 2 plus 1 is nothing but 3 by 2 gamma 3 by 2. Right, 3 by 2 into gamma 3 by 2 can be written as 1 by 2 plus 1. So this also can be written as 3 by 2 into 1 by 2 into gamma 1 by 2. These things already we have been studied in our previous semester in your special integrals, special functions, gamma function and beta function. So 3 by 2 1 by 2 gamma half, 3 by 2 into 1 by 2 into gamma half. Likewise, gamma 5 by 2 plus 1 will be 5 by 2 into 3 by 2 into 1 by 2 into gamma half. So here, gamma half is nothing but root pi. Here root pi and half is common term among all the terms. So we can take common from all the terms as 1 by 2 gamma half. Gamma half means root pi 1 by 2. 1 by 2 means here 2. 1 by 2 gamma half. And also s to the 3 by 2 in the denominator we can found common in all the terms also taken outside. So root pi by 2 into s to the 3 into this term. If I will consider this one, then this term will be 1 minus. Here you can see 3 factorial is there. Here we taken 3 by 2. So 3 by 2 means s to the power 5 by 2 minus 3 by 2. So uh, only we can get 5 by 2 minus 3 by 2 means 2 by 2 will be 1. So s to the power 1. Okay, and here 1 by 2 taken outside, 1 by 2 taken outside, and here you can see 3 factorial and 3 by 2 is there. So 3 by 2 into 1 by 3 factorial. So 3 by 2 into 1 by 3 factorial means 3 into 2. 3 3 got cancelled. So 1 by 2 into 2 or 2 to the power 2. Same thing it has been written 2 to the power 2 into s. Likewise, in this third term, plus 1 by 2 factorial will be there, and 1 by 2 to the power 2 into s to the power 2 will be there. So 2 to the power 4 will be remaining. So 2 to the power 2 here 2. 2 to the power 2 2 by s whole to the power 2. We can write and so on. Okay. So finally we found that Laplace transform of sine root over t, this one root over pi by 2 into s to the power 3 by 2 into this one is nothing but e to the power minus 1 by 4s. How it is? We know that e to the power minus x is nothing but 1 minus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. Right. So here instead of x, we consider as 1 by 4s. If I am going to consider 1 by 4s, here you can see, then it will be 1 minus 1 by 1 factorial. This is 1 by 4s. 1 by 4. Instead of x, we are going to write 1 by 4s plus 1 by 2 factorial. 1 by 2 factorial is there. Then 1 by 4s square and so on. So this is 1 by 1 minus 4, we can write 2 to the power 2 into s plus 1 by 2 factorial into 1 by 2 can be written as, 4 can be written as 2 to the power 2 into s to the power 2 and so on. So this series is nothing but e to the power minus 1 by s. So here in this question, it has been already given that Laplace transform of root sine root t equal to root over pi by 2 s to the power 3 by 2 into e to the power minus 1 by s. But how it will be? Here is the derivation. Okay. Next we are going to go for the Laplace transform, numerical based upon the Laplace transform of integrals. Okay. In our previous lecture, we have been discussed that Laplace transform of the integrals, that means Laplace transform of this one 0 to t f of t dt equal to 1 by s f of s. Here f of s, capital F of s is nothing but Laplace transform of f of t. And also we proved this one, and we are going to use this one to solve these two numericals. So first one is that find the Laplace transform of 0 to t e to the power at dt. Okay, here we are going to use Laplace transform of integrals. By Laplace transform of integrals, that is your in general Laplace transform of 0 to t f of t dt equal to 1 by s f of s. Okay, comparing with the question, if I will compare this and this and this, we can found f of t is nothing but e to the power t. F of t is your e to the power t. So Laplace transform of this f of t is your so-called f of capital F of s will be equal to 1 by s minus a, because already we discussed that Laplace transform of e to the power at t equal to 1 by s minus a. You can check here. Fifth one, Laplace transform of e to the power t is your 1 by s minus a. Okay, 1 by s minus a. Here I directly written that Laplace transform of e to the power t is your 1 by s minus a. Hence, Laplace transform of 0 to t e to the power t dt will be directly by using this Laplace transform of integrals. We can write 1 by s into 1 by s minus a. Now we are going to just verify this answer by doing this numerical traditionally. You can watch here 0 to t e to the power t dt. So here if I am going to integrate this one, integrate, then it will be 1 by e to the power t 0 to t. if I am going to put the limit, then 1 by a, t means e to the rate 0. If I will put, this will be e to the 0 equal to 1. Now this will be the answer of this integral. Now I am going to take the Laplace transform of this one. Laplace transform of this one will be 1 by a Laplace transform of 80 minus Laplace transform of 1, right? So 1 by a is here. Laplace transform of 80 is nothing but 1 by s minus a, minus Laplace transform of 1 is nothing but 1 by s. So 1 by a, if I am going to solve it, then we can find that s minus s plus a by s into s minus a, s got cancelled. So we a got cancelled. We found 1 by s into 1 by s minus a, hence verified. Okay, suppose this question asked in your exam, you can do by using Laplace transform of integrals. It will be easy method, only 2 steps. Within 2 steps you can find the answer. The next question is that 0 to t sine 80 dt, we have to find out Laplace transform, and this question also is going to solve by using Laplace transform of integrals. See, in general, by using Laplace transform of integrals, in general we know that, in general, you just write in general, Laplace transform of e to 0 to t f of t dt, integration of f of t 0 to t is 1 by s into capital F of s, where capital F of s is nothing but Laplace transform of this f of t. And if I am going to compare the question, then this f of t is nothing but sine 80 dt. So it will be 1 by s f of s. Here f of s is nothing but Laplace transform of given f of t. In your question, it is given that sine 80 is your f of t. Laplace transform of sine 80 will be a by s square plus a square. So directly answer we can found 1 by s into a by a square plus a square. Now we can verify by doing traditionally, that first we have to do the integration, that sine 80 0 to t dt, we can found minus 1 by a cos 80 minus 1. So Laplace transform of this one, Laplace transform of 1 minus 1 by a cos 80 minus 1 will be equal to minus 1 by a constant taken outside, Laplace transform of cos 80 minus Laplace transform of 1. Laplace transform of cos 80 is nothing but s by a square plus a square, minus Laplace transform 1 is 1 by s. By simplifying, we can found 1 by s into a by a square plus a square, hence verified. So if in your exam this question or this type of question asked, then you have to use the Laplace transform integral and you can write the answer easily. Okay, no need to write the no need to do traditional method. So in our next class we are going to discuss derivative of Laplace transform. Previously we discussed Laplace transform of derivative. Laplace transform of derivative. Derivative is there of a function. Laplace transform what will be. But here we are going to discuss derivative of a Laplace transform. Laplace transform is there. Then we are going to find out the nth derivative of Laplace transform, and the answer will be this much. Then we are going to discuss uh, Laplace and corresponding numericals also we are going to discuss. Then we are going to discuss integration of Laplace transform and corresponding numericals. So thank you so much for watching this video. Thank you.